Alrighty, it's that time again. So, today, instead of meeting in class and us doing anything kind of lecture wise, y'all all have a game to make. And for some of you, that's a really scary idea, and for others, you know exactly what you want to do. So, what I wanted to do is provide you with kind of a super oversimplified game that you could use as a basis for other games. Now, if you're going to use this, I want you to make sure to add in extra things. Like, you can't just turn this in. If you turn just this in, I'm going to give you like a 30 or a 40. So, add some bells and whistles. And in the documentation, at the end of it, there's a list of things that maybe you want to think about doing to make it better. So, what we're making is going to be a really simple, and like it says, this game is meant to be an oversimplified game where you try not to let the chickens hit the ground. And that's what it is. So when we click, we've got chickens falling. We can click them, and they're falling again. And yeah, they're moving very slow, but this was specifically so that it was easier to see how they fell and tested. And once they get to the ground, it's just going to completely shut out of the game. And that's just a choice. Generally, I would have you put it to a restart screen, or a restart kind of message would pop up. But at its most simplified internal game loop, all we needed to do was for it to shut when we had that. So, okay. For anybody, and this is the code, again, it's linked inside the documentation. It's got more comments than what we're going to do, but it's all commented. And what we're going to do is we're going to come back out to repl. And we're going to create a new repl. So for those that don't know what repl is, those who managed to stumble upon this video because I either didn't make it unlisted, or I don't know, you found it from somebody else. REPL's an online IDE compiler for over 40 different languages. Like, if we click here, it will show us all of the languages that it has, and it just goes on and on and on. And what we're doing is we're building the game inside of the Love engine with Lua. And yeah, Lua's kind of a little bit of an antiquated, well, I wouldn't even say antiquated, it's a language that's been kind of overlooked for a long time, but it is a very user-friendly, beginner-friendly language. So all you have to do is you go to new repl, and repl is free. It has some storage limits, but you can hook it up to GitHub and basically make the storage completely whatever. So you go to Love, and it'll be down here if it's not automatically in your favorites. I make a lot of stuff with it, so it's there. So Love 2D, it'll name it something, and if you want, you can keep that name. Objects Falling Demo. We'll just call it that for now. And then you click Create REPL. So REPL created. There are some downfalls with REPL, like the fact that you cannot put sound into your file currently and it play the sound. And it tends to be a little bit slower because basically, you're building it on this online virtual machine, which is then going to another machine, which is going to another machine, which is then coming back to your machine to see your output. So things aren't always as smooth as they would be if you were running on, say, your own computer, or your own, like if you were running on Love and running on Lua directly on your desktop. So sometimes that can be a little bit problematic, and occasionally you'll see it kind of stuttering even when we take into consideration frame rate and things like that. So just keep that in mind. And the way that we're going to write this is maybe not going to be the way that an advanced programmer or somebody who, I am a programmer, is going to write it. It's going to be accessible for beginners, because most of the people in this class are definitely beginners, are definitely scared of code. So the point is to make it accessible for y'all, rather than write it how I would generally write it for like an actual thing. That's all to say that the way we're writing it is wrong. The way we're writing it is just much more simplified. We're not going to use a lot of fancy functions or lists and things like that. So, for those of you who are in the class, and I'll probably link this inside of YouTube as well, but the first thing that we have that I did, because we've been talking about it, is pseudocoding. So, all we need to do, and all the prompt is, the object of the game is to click falling objects before they hit the ground. Hit the ground and the game is over. Since it doesn't say, that we need to have a restart option or we need to have a game over screen, we're just going to build the internal loop. So that's the idea that if something hits the ground, the thing closes. So with that said, the simplest version of our loop, the simplest version is, while player hasn't lost the game, objects fall from the top at a continuous state. User clicks on the objects. If object touches the ground, player's lost the game. Game over. Like, that's the really, really simple version. But we can also talk about this idea of like what kind of variables we need. So the idea of we need to hold the falling objects, we need to designate the speed, which some of these you're going to see when I actually code this. We don't really use this, but we could. And that's the point for pseudocode. Pseudocode gives you just a solid foundation to try and think about things. So we get a little bit more complicated, but not actually a lot more complicated. So define game over equals false so that we can start. Define variables for falling objects. Again, there's a lot of different ways to do this, and Love does have a form of instantiation, which is creation on the fly. But for what we're going to do, we're not going to do that because that tends to get confusing for a lot of students. So then our actual loop, while game over equals false, so while we're not done playing, start objects falling from the top at a random x value that's constrained on the screen. And see, we haven't said how many objects. And so that could probably be something that our pseudocode is missing. But when it comes to this kind of thing, we know if we make one work, we can make many others work. So we can kind of leave that off. If the player clicks, then if the click is within the bounding box of any image, send the object back to the top of the screen to fall again. So that's how we're like getting that loop of objects falling and falling and falling. The downside of this, that means that we have a static number of objects that are always going to fall, and you could add a few more things to like make more fall and do things like that, or have staggered falls and things. But again, keeping it simple so that it's more understandable. For each falling object, if the bottom of the falling object is greater than the floor, so if it touches the end of the bottom of the screen, then it's game over. So yeah, so that's kind of how that is. And again, pseudocoding is meant to be kind of a bare structure. It's meant to be this super simplified. How do you want your code to end up looking? It's a great way to start thinking logically and seeing where you're going to need different loops and things like that. So yeah, there are variables missing, like I said down here, such as we can make variables to define the screen width and height. But because we're using Love and Lua, we've actually got access to those really easily. So, yeah. And for those of you who have this document, it is split into sections. So we have coding, but then we have things like adding the image to use. So it is split into sections for you guys if you want to use the navigation tool, if you have Word open. So, okay. So let's go ahead and start thinking about how we're going to code this. Now, if we remember, or if you don't remember and this is your first time looking at it, Love has 6 lines that are basically included in every game. To make a function, we start typing function, and then love.load. You know what, let me go ahead and make this. That looks a little bit better. So function love.load and end. And then function love.update and end. And function love.draw and end. So for those of you that are new to Lua, basically everything uses the word end to show that it is stopped. If it's a loop, it's got an end at the end of it. If it's a for, it's got an end at it. If it's a while, if it's a function, it has the word end. And that's nice, especially for those of us, or those who maybe don't feel as good about their programming. This is a way to specifically say, hey, I know that I'm stopping this loop. This is where I'm stopping this loop. So that gets really nice. So the one thing that we do have to do, this function is a function on its own. That's fine. It can be that way, no problem. But what we actually want to do is we want to add a parameter in here. And the way that Love does it is that they call it dt. And all dt means is that it's delta time. So delta time is where it shows us the amount of time between things. So how we're using it here is we're going to say, hey, so instead of just taking our speed every frame, we want to see how many seconds or how many milliseconds have elapsed between frames and multiply whatever our speed is so that we know that we're getting a consistent speed. Because the problem with frame rate is that frame rate doesn't work at the same pace. Those of you that are gamers, you've all played those games where you're getting that great 60 frames per second or higher, and then all of a sudden you tank down to 12 for whatever reason, and then you shoot back up. So we know frame rate is variable. And this makes sure, adding delta time, it helps it so that it doesn't look like it's variable. So things move with time. And that's all that means. So after we've got that, we have to add our image. And the image that we're going to use is from kenny.nl. And kenny.nl allows for us to use free assets with some attribution. So if we come in here to assets, and he has some paid ones, and totally if you're enjoying what you use, 100% pay for them, or like get one of his pay packs, because yeah, they're amazing. They're applied, or they're supplied for us. We can switch it over to 2D. I did the demo on my other computer and I realized that I don't have the images on this one yet. So where are you at? And all we're looking for, and I've probably already passed it, is this animal pack. See that animal pack? It's not the animal pack, it's the new animal pack, which is probably on the front page. But basically, you can pick whatever you want. Let's see. So, this one. I want this one. Because I want that little chicken right there. I mean, you could use whatever you want, but you're going to see it's, hey, download this stuff. It's going to take a few seconds to download. You're going to extract all. You're going to extract it. Life is good. You can see it's a lot of different items for free. And they all look the same. They all work the same. It's great. So once we're inside of here, you're going to be able to see, we've got PNGs, we have a sprite sheet if you want to slice your own sprites. You have all sorts of extra things. So when we come back over here to add an image to repl, all we have to do is we have to come in here and we'll go into our PNGs. I think I just used this one, and grab the chicken or whatever you want to use. You want to make it falling owls or falling mooses, or cows, whatever you want. I like the chicken. We're gonna drag the chicken over here, and that's it. Life is all good. So then, because of the nature of Lua, the nature of Love, we can't randomly use this image. Like, this image doesn't exist inside of our game. We have to put something inside of load for it to be able to use it. So in this case, we're going to call it rooster face. And we're going to say... And now, the one other thing is that Love and Lua don't care about spacing or tabbing or whatever. But to make your life easier, my suggestion is to always tab at least one over. So what we're going to do, rooster face equals love.graphics.new image. And then we're going to call the name of the image that we have, so chicken.png. And this only works as long as this image is in the same kind of folder as main. Like if you had another folder here and then this was in that, you'd have to call the full thing. So just know that that's how that works. So, and all this says is, hey, we want to access inside of Love the graphics library, and inside of the graphics library we want to access the new image, and we want to make a new image using this. And so then you have all sorts of things that the image class has that you can provide to chicken.png. So right now, if we click play, and I didn't write something stupid, it's gonna, and you're gonna see sometimes this, okay, nothing shows up. And that's because all we've done is loaded the image. We haven't done any kind of work to get it to show. So to get it to show, we actually have to draw it. So that's, again, another one of the things that Love does really well, is that these three functions, they say exactly what they're doing. So to draw it, we access love.graphics.draw. So we want to draw something using the graphics of Love. And we want to draw the rooster face, and we want to draw it at 0, 0. Now for this engine, for Love Engine, 0, 0 is this top left corner. And this is important because for some engines it's the bottom left corner, for some engines it's this center. Now there are a few kind of extra versions of draw that you can use. And some of them, if you need scaling, if you want to change the tint or the alpha, you can do a lot of that inside of here. But this is the basic version of it. But it's not uncommon to see one that has like 4 variables in it, and that generally has to do with scaling. So if we press stop, and again, repl.it's really nice, so it'll let you type while it's still playing and not show anything. If we play again, and again, if I've spelled everything right, which may or may not happen. There we go. We've got our rooster face in the top left corner. Now it's important to realize that this image, even though it has these transparent corners, that's still considered part of the image. So when we go to do our mouse clicks, if you click up in this top corner up here, it's still going to register because it's part of that square. Well, it's not really a square, it's a rectangle. It's gonna access those areas right there. So that's kind of important to realize, and I'll reiterate that later down the line. So now we have a chicken. Yay. So in your mind, it may seem logical that the next step is to make the chicken fall, but the easier one to do is to make sure that you have your clicks working so that you're not having to chase your chicken around trying to click it if you made it too fast to begin with. So we're going to look at how we click on the chicken to make sure that we're clicking on the chicken. And basically what we know is that we want to make sure that the mouse position is greater than the X position, or the X position, and less than the width of the chicken, and greater than the Y position, but less than the height of the chicken. Because remember, 0, 0 is the top corner, so we're doing everything off of this corner right here. And to do that, the best option is going to be to get some variables so that we know, and eventually we're going to use these variables to make it move or to make it change positions. So let's call them start X, and we're going to say, hey, that equals 0, and start Y, that also equals 0. So instead of these 0, 0s down here, we can say start X, and start Y. And that means whenever we move these variables, either through here or if we change them inside of update, that the chicken will move to match those. That also makes it easier for us to say, hey, like, where is the click area? So believe it or not, well, I mean, I guess you've got to believe it. Blindly trust me. Yeah, that's a good idea. Lua and Love together have a built-in function for mouse presses. So for that, we're just, and I like putting it between load and update. If you guys have watched other tutorials, some people like to put it inside of update, some people like to put it after update. And it's really kind of a personal preference as to how you do it. I like doing it here. So we have function mouse pressed X, Y, button is touch. And the way that I like to do these, because I don't want to forget to type that end in, is I always add the end as well as the function declaration. So what does this mean? This checks to see if a mouse is pressed, what the X and Y location that it's been pressed at on the screen, which button has been pressed, and whether it's been touched or released, kind of thing. So for us, this makes it really easy, because all we have to do is say, hey, if the button is the left click, and in this case left click equals 1, then, and this is how Lua writes their if statements. Those of you who have taken other languages like Java and C++, you're like, hey, where is that? That then doesn't exist there. In Lua, it does. In Lua, so, and if you talk to old school programmers, they're going to tell you, they're going to refer to this as an if-then statement. They will always pretty much refer to if statements as if-then statements. Though if you talk to new school, it's always just like an if statement. And that's why. Because older languages, Lua's a newer languages, but it has a lot to do with old languages. So that's what that then is there for. So, and we added our end. So if the left click, which is equal to 1, has been pressed, for now we're just going to say, hey, let's write a debug log. Let's print to the console down here. And we'll print left mouse clicked. So, again, we're getting the X and the Y position, the button, and whether it's been touched. So right now, it's not going to matter if we click on our chicken. It's just going to register when we click anywhere inside of the window. You see, when we click outside of the window, it doesn't register. But as soon as we click inside, it registers. So by default, as a side note, Love makes this 800 by 600. However, inside of repl, it has a problem with showing the very bottom of the screen, and we'll see that when the chickens fall. So yeah, so we can click stop. So we know that this is working. We know, hey, our mouse press is working. It's doing what it's doing. Life is good. So, again, we have to figure out, we want to get, from this top corner of the chicken, to the width of the chicken, the top corner of the chicken to the height of the chicken. So we want to be able to only register clicks within like this little rectangle. We don't want to register a click if we're out here. We only want to register if we're inside of here. And that's the logic behind it. This idea that we're getting the width and we're getting the height. Now, there is a problem if you use image scaling when you draw it. Because image scale only affects the way that it's drawn. The bounding box that's on it actually still stays the same size, which can trip you up. So if you're going to do any kind of image scaling, you have to also image scale inside of like your collision check. So inside of the checks that you're going to do, like inside of here. So we're going to comment this line out, which is 2 little dashes, unlike your slashes or hash marks in other languages. So, and again, we talked about this. We want to know, hey, we want to say if the position of the mouse, so X, is greater than or equal to start X. So if it's greater than that 0 on the x-axis, but also less than start X, because we need to get that start point, plus, and this is one of the best things, there's a built-in function for getting the width and getting the height of an image, and to do that, all we've got to do is rooster face colon get width, and then we also want to check inside of here whether we've got the same thing going with Y. Like, it needs to be both. It can't just be one of them. It has to be both of them. Now, because Lua doesn't care about spacing or anything, we can just press the Enter key, and I do a lot because it means that I can get this to look nice. Now, we want to say, is Y greater than or equal to start Y? And we want this to be an and, because we have to have all of these be true. We have to have everything being true for it to actually work. And you want Y to be less than or equal to start Y plus rooster face. And just like with get width, we have get height. Now, one of the nice things about not using repl is that most of these will pop up if you have a dedicated Lua or Love IDE. So you have to memorize a little bit more, but it is handy because it's all online. And you don't have to download anything extra. So if it's just something that you're dabbling in, repl's great. If you're wanting to do something more extreme, maybe not as great. So, okay. And then we can't forget then, that last little word that we need. And I'm going to come down here and write my end to it. And you can see how it gets better when we're tabbing, because we can start to see how these all line up with each other, just the same way that you use curly brackets inside of other languages. That's something that some of you may have noticed and kind of freaked out about, is that we're not using semicolons to end each line. Lua will take them, but it doesn't need them. So basically it says, no, we don't need them, but if you put them there, we understand you're coming from another language and that's the way that you want to write. So it lets you. So in this case, I'm going to go ahead and tab in twice just so that I can get outside of that if statement. And all we're going to do for now is we're going to print, and we're going to print in bounds. So now when we run, and if I haven't written something wrong, which again is always possible and it happens more often than not, we're going to see if we click outside over here, aha, I did something. So it says, hey, main Lua 11, attempt to perform arithmetic on a global start X. And that's because I didn't capitalize this X. So again, I knew we'd see at least one of these problems. And this is really helpful. This is not so helpful. Like, it does say main 11 Lua something something something, but where it's really going to be helpful is it's going to be inside of this. So main Lua 11, attempt to perform start X, a nil value. So for those of you who don't know what a nil value is, inside of Lua has its own kind of representation of nothingness, and that's a nil value. It's literally something that contains absolutely nothing. It's an empty box, and they call it nil, which is great if you're doing things on the fly, or if you don't want to initialize a variable right away but you want to use it. Nil is what values are given that aren't kind of assigned. So now that that's fixed, inevitably there will be another error, because there will. Okay, so yeah, so we're clicking outside of here and nothing's happening, but when we click inside of him, it's happening. And again, remember, if we click inside these corners up at the top, if we click on top of these corners up at the top, it's still going to count as inbounds because it's inside of that rectangle. And yeah, there are ways to get around that and ways to fix that, but for something simple like this, we're just going to leave it alone. If you really want to be adventurous and figure that out on your own, go right ahead, or just use cubes. Yeah, just use cubes. So, now that we know that this is working, and that's all we're going to do for now, because we haven't really told it to like restart at the position, because we're not moving yet. We're going to get the chicken to move. We're going to get the rooster to move. And that's where this whole start X and start Y thing is really handy. And the start X and start Y is really handy because it means that we can manipulate directly off of those. Now, one of the things that I didn't like, and I guess, gets a little fancy, is that the rooster just kind of starts on the screen. Sorry, I had the hiccups. And that doesn't make for like the most aesthetically appealing thing. Maybe we want it to fall off of the screen. So it's really easy to do that. And again, that's just by manipulating the start Y. And we're going to take start Y and we're going to subtract, or we can multiply by -1, or however you want to do it. But we're basically going to subtract the height of the rooster face. So we're just going to do start Y equals 0 minus rooster face, and then get height. That's it. So now we know that it's going to start just off the screen and then it's going to fall down onto the screen, which is great for us because that means it's going to give it more of a movement kind of situation. So now to actually get it to move, we're going to come down to our update function. And inside of update, all we have to do is manipulate that Y value. That's literally all movement is. It's just manipulating the Y value or the X value, or both of them depending on how you're wanting to move. But in this case, since we're just having them fall from the ceiling, it's just manipulate the Y value to go down. So, and sometimes you'll see that that's like add 1 or multiply by this. And depending on how you want to do it, like if you want acceleration or something like that, you may have more variables. It just depends on how you want to do it. And generally, you would also have something like a speed variable up top that you would manipulate, but since this is the only place that we are doing speed, I went ahead and hard-coded it in. So we say start Y plus 20, so that means, hey, every frame, I want you to add 20 pixels, so I want you to go down 20. But what we're going to say is, hey, multiply that by dt, and all we're saying is multiply 20 by dt, so that we know that it's going over time. And again, that's so that we get around frame rate. Now this number is big like this because we're multiplying by dt, which is going to be like 0.001 or 0.09. It's going to be very small numbers. So we end up needing a bigger number than what we would if we were saying, hey, move without this. So that's kind of how that goes. And the reason why it's written this way, and the reason why it's only these two multiplied and not this one, is because we're looking at order of operations. Those of you who've taken math recently, you probably know PEMDAS, or please excuse my dear Aunt Sally. Lua has something similar. They've got a few things that kind of change around, but the big one to remember is that multiplication will always come before addition, so it will always evaluate the multiplication before the addition. If this really bothers you and it really hurts your head to think about that, you can also write it this way, so that you know that that's first, or like switch it around so that it's in the order that works for you. They're all right, you know. Do what works for you. Do what makes sense to you, especially if this is a beginner coding class, or maybe it's not something that's for your major and you're just trying to get a handle on it. 100%. There's no shame in making things make sense to your brain, because the reality is, if you're having to like switch things around to make sense to you, there's a good chance that somebody else reading it doesn't get it quite right, and that they need you to fix it as well. So, yeah. You do you, guys. You do you. Now, when we start playing, again, if I haven't written something wrong, which is always a possibility, we're going to see our chicken falling. And we're going to notice, like, we can't click, but when we click on the chicken, even when he's moving, and we're like, if it's above him, it no longer counts. Or just the chicken. And at this point, he's going to go and keep going forever and ever and ever, and he'll like fall off the screen. If you wanted to see the difference here, if we take DT out and we click play, he's going to move a lot faster. And it may not be 100% noticeable. See how he was basically immediately gone? It may not be 100% noticeable that there were issues with the frame rate, but there were, I promise. So that's all we need to do. Okay, so at this point, believe it or not, we're basically close to finishing this game. And all we need to do now is kind of, you know, either work on the game over functionality or work on returning the chicken back up to the top once it's clicked. And it's kind of a catch-22 on which one you want to do first. My opinion is to do the return back to the top, so get it to work like an actual game before we do a game over. Just because it's how I work. But that's not to say that you would want to work the opposite way, where you had the game over function in first and then added in all the extra stuff. So, I'm going to do the whole returning and adding in some extra things. So yeah, so getting it to return to the top is relatively easy. And that's where we have this inbounds thing. So instead of inbounds, we want something to actually happen when we click it. So what we want it to do is we want it to go back to the top. So we want it to say, hey, start y equals 0 minus rooster face get height. We've seen this already. Like, that's how we started all over again. Now what we may want to do with that is to get it to like put it on or change the x value, but we'll do that a little bit later. Yeah, we'll do that a little bit later because that involves again doing another kind of get with thing. Yeah, random will be fun. So but the whole problem with this, and the reason why I have a problem with just doing it this way, is that then it's the same loop over and over and over and over. So every time we click it, it's going to start at the same point. Like, we're always going to see that little bit of a chin underneath there. So what we can do instead is add randomness in. And Lua's random is dumb. Like, there's no two ways about it. What Lua does for random is it has created a static number chart, and it's full of random numbers, but it's the same random number every time you start again. So it's not really as random as we would want it to be. Thankfully, because Lua is built on top of C, we have some access to their different things, so we can actually randomize their random. So what we're going to do for that and how we're going to do that is that we're going to say, hey, math.random seed. So we want to make a new seed chart. So we want to make a new chart of random numbers. And what we're going to base it off of is os.time. And this is pretty much the preferred kind of thing for general, easy kind of randomness. Now, once we do this, we actually have to say, hey, we need to make sure that it's actually random. So we call math.random without any kind of parameter or anything 3 times. And that just, if you've ever heard the phrase, prime the pump, it primes it. It makes it gets rid of all the old stuff and makes sure that it's like got a brand new good thing. Now, what we can do down here is we can then say that instead of just saying, hey, this equals, you know, the same spot every time, we can change it so that we're going to use math.random. And we can say 0 minus, and you can either do multiply by -1 or minus, however you want to do it. Really, however you want to do it. But we can say math.random, and then in our parentheses, we can say that we want this to be the lowest. And Lua's, and sees random is inclusive. So it includes the low and it includes the high number. So some languages only include the low and they don't include the high number. Some include the high number but not the low number. Some don't include either. So this one includes both of them. So we can say, hey, we want this. And then for the high number, and this was just an arbitrary kind of thing that I picked. You could pick something different. Again, it's a lot of testing and seeing what feels good to you. I'm just doing the same kind of get height for the rooster face and multiplying it by 2. So it's going to work somewhere in there. And the same way that we did this is how we're going to do our x value. So, sort of. We're going to do it slightly different insofar as instead of looking at the height of the rooster, we're going to look at the width of the entire scene. So to do that, we're going to say 0 is our starting point because the lowest we want our x to be is at 0 because it's the left-hand side. And then the highest we want it to be is the screen, which is going to be love.graphics.getWidth. And then we're going to subtract our rooster face and the width of it so that we know for sure that the closest it can get is like 1 full face away. And then this needs to not be start y, this needs to be start x. So now we're going to have it randomly kind of showing up and randomly doing its thing. So if I haven't messed it up, we'll see. It happens. When we click it, it's going to take a little while. It's going to take too much time. So at this point, it means that I've done something to it to make it not do what it needs to do. So let's take this guy out and see if that's the problem. So yeah, you're seeing him come back down, and it's just taking a little bit more time. And it's kind of a variable amount of time. So, what did I do on this one then? Start x equals 0 minus... Oh, that would be why. Because we don't want it to be negative, we just want it to be the positive. So, now when we play... Because what that was doing was it was putting it all over here, not inside of here. So now when we click it, we should start seeing him in random spots. So see, he's like popping in at random places, both in the Y and in the X. And if you really need to, you can 100% debug log it, so add a print to the console statement to see like what exactly is happening. And it's all up to you. So now we have it clicking and it's moving back up to the top and it's changing positions. Life is good. So what do we do next? Well, I mean, 1 rooster is kind of boring, right? So let's add some more roosters. How about we do a total of 5 roosters? And there's a bunch of different ways to do this. You can instantiate, you could create a function that kind of did multiple roosters, but the easiest way for people to understand, or the easiest way for new beginners to understand, is this idea of just making 5 variable sets. So to do that, we're going to switch start x and start y over to tables, which is Lua's equivalent of arrays for other languages. And those get a curly bracket around them, just like that. And sorry, I 100% lost what I was saying. Basically what we're going to do is we're going to have... We can leave this for start y for all of them, but eventually we're going to randomize it. I mean, we could just randomize it right now because we already have this written for us. So if we just grab this, all of this, this is what it's going to be for each one of these. So what we can do is we can say, hey, you know, or grab this one right here. But we're going to go ahead and replace that. And again, these get kind of long, so just note that that's a thing. But you're basically going to do that, and then you're going to do a comma. And you're going to do a comma. So that's 3, 4, 5. So, and again, the way that I like to do this is to get these so that they all line up together, just so that it's easier to see where everything is. So we've got 1, 2, 3, 4, 5. So again, we want to match that with the X. And for the X, we're going to grab this guy. So this math random blah 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 blah. And if you try and test this right away, it's going to break, because now that we have arrays, it's not going to recognize these numbers. It's going to recognize this as a table and not as a single object. So we're going to have to fix that in a minute. So one, 2, 3, 4, 5. So now we have 5 and 5. And so these are our X values and our Y values. And yeah, with the table, you could 100% kind of match them together or put them all in one table. You could instantiate. You could do a lot of things that would make it not do this, but it's kind of up to you how you want to do it. And to be entirely honest, this is relatively easy. It looks clean-ish. It's at least, you know, it's understandable. And that's what this is about. I'm not talking about making something amazing and that works like great, but I am showing you guys something that's functional and easy to hopefully understand. And so once we have all of that, if you want to check it, if you want to figure out whether it's working, if you change all of these over to 1, so anything that says start X or start Y, if you switch it to the square brackets, and that says, hey, take the first element and like apply this stuff to the first element. Now that's another one of those things that's a little weird about Lua. If you guys are used to Java or C++ or C# or a lot of other languages, generally your arrays start at 0. Lua says no, that's confusing. Lua says let's start at 1. And it does. So that's something to keep in mind. It starts at 1, which makes it a little bit easier when you're trying to find like the end or how long something is. But yeah. So now that I think I managed to get all of these, and it'll tell me if I didn't, we can run it to see how it's going to run. It's thinking. It's doing its thing. Occasionally repl will crash and just like refuse to do things. So we've got our one guy and he's falling and everything's great, and when we click him, he's going back to the top and figuring out where he's going, maybe. So yeah, he's coming back down. And that's not to say that he's always like, see, he's moving slightly, and that's the whole point of randomness. You don't quite know where he's gonna fall from, but he is falling, and that's what matters. So, and again, the speed is slow, but that's specifically so that it was easier to kind of test all this stuff out. So now that we've got that, how do we change like every single time? How do we make this? We're not going to write this 5 times, are we? I mean, I guess you could. You could. But that's a lot of damn writing. I'm sorry, that's a lot of writing. Most languages have what we call a for each loop. And basically it says for each element in an array or a list or a table, apply this set of things. And generally, they're relatively easy insofar as they're written literally like that. For each thing, do this thing. Lua, unfortunately, takes a little bit of a harder approach to it, so that it looks more like a for loop. Yeah. And that may or may not jive with you, but it is relatively easy once you start figuring it out. And once you figure out one, you can copy it everywhere else. So the first thing we're going to start with is we're going to start down here in our graphics, or in our draw. So we're going to say, hey, for the index, so I, and the value that the index holds. So in block 1, what's held there? And then we're going to say in I pairs. So the reason why it's called I pairs is because Lua has 2 different for each loops. One is if you have I pairs, so if you have something that has an index, which is what we have because we haven't specified an index. You can also, because Lua is funky and it works kind of like a dictionary, their tables, you can also say, hey, I want the index to be named. And that gets really complicated. So we're just using I pairs, which is just when you just write things out like it looks like a normal array in another language. So for I, so the index, and the value that is at that index in I pairs, and then we're going to name it, and we can do start X or start Y, it's really up to you. I'm doing start X because it's the first one I have. And then we say, hey, do, and again, just like everything else, we have to put an in statement. Now, this gets really easy because all we have to do is we have to change this over to an I. And so this will iterate through the entire table and say, hey, okay, so for 1, do this thing. For 2, do this thing. For 3, do this thing. For 4, do this thing. For 5, do this thing. And then it'll end, and it'll be happy. Because we've moved these so that you can't see them from the top, we're not going to actually get to see more than the first one. So testing it at this point isn't the easiest. And if you're following the documentation, it's because the reason why you can see 5 on the screen is because I haven't switched that Y value up to be the top yet. So now we've got to do this, and basically you can copy this right here. It's fine. Just copy that line. And you're just going to add it everywhere. Basically, anywhere where you've got these ones, you're going to add it. So inside of where we're changing our speed. Sorry, again. Seasonal allergies are trying to murder me. We're going to switch this over so that we have this again. For the index and value paired inside of start X, change the speed, or change the location, so make it move, of the index thing down, and just keep doing it. Just keep doing it. You know, it's a Dory moment, just keep swimming. So now we've got to deal with this guy, and this guy seems a little intimidating, but the reality is that it's literally the same thing. So we're literally going to come in here, we're going to say, hey, let's get that back to where it needs to be. And then we can highlight everything through here, and we know that that's the end statement for that if, and that's the end statement for that if, and that's the end statement for that if. So we can tab it over, and we can just add another end statement here, and then switch this guy over to eyes, and that's all there is to this. And then you just have to remember where they all are. And I'm not gonna lie, I probably missed at least one of them. And now we should, if I didn't miss any of them, be able to see all of our roosters falling and all of our roosters playing nicely. So yeah, so we have all of our roosters, and if we click on them, they're going away. Now, you see how like multiples were going away when they were like stacked like that? There's a few ways to stop that, but the easiest way to stop that is not going to be the prettiest way, but it is definitely the easiest way. It's at the end of here where you say, hey, if the start blah 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 blah, and to add in an int or a break statement. So where you have this kind of randomizing, at the end you say break. So another really weird thing about Lua and Love is that Lua has a break statement, but it doesn't have a continue statement. And what this does right here is it says, okay, so I'm in the middle of this, like going through all the pairs. The first pair I run into that meets this kind of qualification, do it, and then don't do any of the rest of the loop. Like go back to the beginning. And so it will only grab whichever one, like, so if it's inside of here, if it's the first element, so it'll do that one and that one. But it doesn't matter whether this one is behind or in front, which can get a little weird because the way that Lua and Love draw things is that the first one is at the bottom, the second one is at the next bottom, you know. So it's order of operation, or not order, it's the way that the sorting order is. So it'll always grab the thing that's behind everything first. And you have to do a little bit of extra work if you want to get it to do the other way around. But now, if we have something fall on top of each other, you're going to see how it clicked the one from behind. But yeah, but the point is that now it's you got to click multiple times to get these guys away. And again, you can make it work another way. This is just the easy, bare, basic way for you guys to do this kind of thing. I'm not showing you, I'm trying to not show you guys anything super fancy or super overwhelming, because I wanted to keep this simple so that it's hopefully digestible. And really, if you don't want the break statement there, you don't have to have it. It's kind of up to you what you want it. So, we pretty much have a working game now. The only thing we need is that game over functionality. That's it. That's all we need. And because, like I said, we have this whole idea of we didn't need a game over screen, we didn't need a game over pop-up, we didn't need anything like that per the brief. We can just end the game if something hits it. Again, is that the nicest thing in the world? No. And if you're turning this into me, it better not just shut. It better be like, hey, you finished, or hey, you're done, or have something that tells me that. But to at least get that internal loop working, we can just shut it for now. And if you need help on making it like pop up game over or something like that, let me know. It's just an if statement. Really it is. Or a while statement. It depends on how you want to do it. But it's really simple. So what we have to do to get this to quit is really, really easy. Believe it or not. We just do a new statement inside of update. Now we're going to check to see if it's hit the ground before we update the speed, etc. So for that, all we have to do is say, and we've done this already, we're saying, hey, if the height is less than the window height, or greater than the window height, then it's over. We're donezos. So what we can say is we can say if start y I, because again we're going through all of them and checking all of them, plus rooster face get height. And the reason we're doing it this way is because start y, so that y value is that top left corner. So we need to know what the bottom is. So we need to do whatever the start y is, so that top left corner, plus its height to get the bottom y. And then we have to say if that is greater than or equal to the height of our window, so love.graphics.get height, then, and again, we can put the end statement in. It just depends on how we want to do it, or how you want to do it. And to start with, because I want to show you that it works, we're going to do print over edge, and I'm going to switch this up to 50 just to give it a little bit more speed. And when we click play, it's going to think about its life and what it's done. And then we're going to see, and this is also where you're going to see this kind of graphical issue where it cuts off the bottom of the screen for whatever reason. And so it didn't start actually printing over edge until it got further down. So, and now it's just, it's continuing to go, so it's going to just keep printing. So actually, let's do that again. That way it's easier to see my printout. I can see it, but I don't think you guys can see it. Okay, so see, it kind of waited until it was like right over the edge to do that. So it's a little bit like you can adjust that, but if you were to actually publish it, it would be fine. Again, sorry about that. So what do you do if you want to quit? Well, you could write some big convoluted thing that makes it close, or you can use love's quit. It has a quit function built in. And all you do is love.event.quit. Now, you can also change quit into here to be reset, and it'll reset everything back to the beginning, but it's up to you. It's up to you how you want to do it. If you just want to keep this a continuous game until they close out of it, reset's a great idea to use. This brief only says, just quit the game after they've lost. Which is fine for this specific thing, but I do not want that in the one that you guys turn in. So with that said, now once we play it, and once we get these guys falling, and yes, there are ways to get it so that they don't cluster like that. It does require, I've given you all the code that you need to do it. And you can see, it completely shut out, it's done, it's stopped, everything's great. As soon as one went over the edge. But yeah, so there is, based on the code that we have now written, you should be able to figure out how to get it to not cluster on top of each other, if that really, really bothers you. If it doesn't bother you, then, just leave it be. So with that said, in 52 lines, and probably those of you who don't space things out, under 50, probably closer to 40 lines, we've written something that's, a game in quotation marks insofar as it runs and it has activities for you to do, or it has an activity for you to do. Of course, that doesn't mean that that's what you should turn in. Like I said, if you turn that into me as a game, I will give you a 30 or a 40 and frown at you. It needs to have more functionality. It needs to have more things. So I actually, inside of the document, have some things that I've written out just to kind of make it more fun. So add in power-ups and debuffs that fall or maybe move in different direction. Randomize the animal images. Add in a score for how many you clicked. We looked at text previously, and you'll just have to look at it. Remember that Love has a great wiki for how to change text, how to change sizes, how to change colors. Remember that if you change a color and then you draw your images, that they will change to like weird funky colors. So always make sure to set the color to white before you draw your images. You can add in a score for how many times you clicked, which would be cool, and that would be a great way to do a reset. You could have the score and see how high you can get, and then once you hit, it does over. Maybe have live so that you can hit the floor 3 times. Create a background. Don't just leave it just a black screen of grossness. Make it actually make sense. Why are there chickens falling from the sky? Increase the speed the longer the game is played, and that's just an acceleration. For those of you who have me for game scripting, you can look at the rocket code that I have for the complex, or whatever I called it, advanced rocket, that's got kind of acceleration in it, and you can apply the same kind of principle here. Or you could have a counter, and so for every time the counter goes up or whatever, you increase the speed by 1. Yeah, you could increase the number of things that get on the screen the longer the game is played. You could
change it from being where you're clicking things, which is kind of, for some of y'all, that's really boring clicking. I don't like cookie clickers in general, but I also understand their appeal and was around when they were like first a thing. Um, so yeah, I mean, it's possible. It's something that you could do if that's really what you want to do. But you could also change it over to have a sprite where it's like an actual character that you control with your left and right arrow keys, and you're trying to either catch things or or avoid them falling on you. And that would literally work the same way that we've done collision. Like, the same way instead of checking if just the one mouse point is, you would just check if the whole top of your character had touched the bottom of the other thing. So you technically know how to do that based on what we've done here. You could add a timer, which again, timers are relatively easy to add in because you're looking at your OS time. And there is a timer in the maze game that I provide you guys that I did. Those of you who don't have me for game scripting, if you find the link to my REPL, you can 100% go in and peek at all the other code. It's messy, but it's there. You could add an intro screen with directions how to play because, nobody's going to know what they're supposed to do. They're just going to see a bunch of fallen chickens. Add a game over screen or a play again pop up, maybe with keys. Press this button to exit, press this button to play again. You could create different levels where they move in different directions. You could have them just bounce off the walls, and anytime they bounce, you get a negative score, and once you get to, 0 or whatever, that's when the thing fails or game overs. There's lots of other things, and I'm sure some of you are like, oh, well, it would be cool if we did this, or it would be cool if we did this, or it would be cool if they broke into smaller chickens, or pooped eggs at us, or, this would be even a way to start working on Space Invaders, so something like that could work with this, or you could probably get Arkanoid to work off of this, those kinds of things. And then, again, this is not meant to be the best way or most efficient way to code this. It was meant, and hopefully was, beginner friendly and understandable for those of y'all who do not like to code. There are ways to instantiate, there are ways to create things on the fly that would have probably been a better option. However, this is pretty lightweight as far as how it works. It is also light on functions. There are a bunch of things that we could have done with functions that may have made this a little bit better, and we wouldn't have to do so many for each loops, but functions can be confusing for a lot of y'all. A lot of y'all, especially with beginner classes, you don't learn about functions until 3/4 of the way through the semester, or you do, but you don't really know how to use them, and your professor doesn't enforce them, so you write everything in main. So that's kind of what I kept with this. I kept this as simple as I could in one place so that it was understandable. And yeah, like I said, the code with the commenting is available here, and that's public, so those of you who aren't in the class can 100% click that and find it. And it's got commenting in it. It does show you all the commenting. And hopefully this has been helpful for those of y'all who don't know what to do for your midterm game. And anybody else who's managed to stumble across this, hopefully this has been at least not a waste of your time if you're at the end of it. So yeah, send me questions if you have questions, and I'll try and answer them as best I can. And for those of you who are in my game scripting class, I will see you next Saturday. Yeah. Have a great weekend.